In this video, I am going to explain the experiment electrical resistivity. The objective of this experiment are to study the effect of dimensions on the resistance of metals. And the second main objective is to determine the electrical resistivity of metals. In this experiment, we are going to use two different metallic wires. The first one is nichrome wire and the second one is brass wire. And here we are going to find its respective electrical resistivity value. The apparatus we are going to use in this experiment are a resistance apparatus, metallic wire set, two digital multimeter, DC power supply, connecting wires, and key. And I am going to show you the video to show all these apparatus. Apparatus used in the experiment electrical resistivity are, we are going to use the power supply, two multimeters, and we are going to use the resistance apparatus. By using this resistance apparatus, we are going to find the resistivity value of two different materials. What are the materials? Here we are going to take two different materials. The first material is a nichrome metallic wire, and these four wires are brass metallic wires. And apart from that, we need the key, and also for connections we need these connecting wires. So these are all the apparatus we are going to use for this experiment. The main two equations we are going to use in this experiment are resistance R equal to voltage divided by current, and resistance R equal to resistivity multiplied by the length of the material divided by the cross-sectional area of the material. As we already mentioned earlier, in this experiment, we are going to use two different metallic wires. The first one is nichrome and the second one is brass, right? So here, what we are going to do, we are going to find its respective resistivity value by using the second equation. So for that, we have to rearrange this equation in terms of resistivity. Therefore, resistivity rho equal to resistance multiplied by the cross-sectional area divided by L. By using the value of resistance, area, and its respective length, we can easily find its resistivity value. The experimental setup diagram was given here. Based on this circuit diagram, we are going to give the connection by using the apparatus. Clear? So let's see the apparatus here. So what we did here, we take the connection from the positive end of the battery. That means the positive terminal here. So from the positive terminal, we gave the connection to the key. And then from the other end of the key, we gave the connection to the first multimeter. So this multimeter is going to measure the current. So you can see here the pointer indicating the ampere. That means this multimeter is going to use for measuring the current. And then from the other end of the multimeter, what we did, we gave the connection to the resistance apparatus here. So we can see here the resistance apparatus connection for one end is given here, and from the other end of the resistance apparatus, again we connected to the negative terminal to the battery. Clear? So from we are going to use another multimeter. So this multimeter we are going to use for measuring the voltage. So you can see this pointer is indicating the voltage. So we are going to connect this voltmeter exactly parallel to the resistance apparatus. Now what we are going to do, we are going to take the first wire. What's the first wire? The first wire here is nichrome wire. We are going to take this wire and we are going to connect that wire in this resistance apparatus. So this resistance apparatus is used for measuring the resistivity value of this nichrome wire. Clear? Now what we are going to do, we are going to take this nichrome wire and we are going to connect this nichrome wire in this resistance apparatus. So what is our main aim of this experiment? We are going to find the resistivity value of this nichrome. So what we have to do, we have to take this wire and we have to connect in this resistance apparatus. Now you can see here we connected the nichrome wire in this resistance apparatus. Now what we have to do, we have to fill these two tables. So in the first table, we are going to take the data by using the nichrome wire which we already connected in the resistance apparatus. And also we have to give some initial voltage. So how much voltage we have to give here? Here we have to give 5 volt. And also by using this current knob, we have to set exactly 1 amperes in the multimeter. So this multimeter is going to use for measuring the current. So by adjusting this knob, what we have to do, we have to set 1 ampere here. So the initial setting value is 5 volt, and then we have to set 1 ampere. So throughout this experiment, what we are going to do, we are going to maintain the current as a constant value. We are not going to change anything. We are going to make the current as 1 ampere here. Clear? So now what we have to do, we have to find its respective voltage. And before that, you have to see the first column. So what is given in the first column? As I already mentioned, we are going to use nichrome wire. So better I can mention the wire name. So nichrome wire we are going to use here, and we have to measure its respective voltage for different length. So how to set the length here? So this length should be fixed in this resistance apparatus. So now you can see here we have the 2 pointers. One pointer is in the extreme left hand side and another pointer in the extreme right hand side. So what we have to do, we have to set the first pointer to 0, and then we can move this pointer to 24. So where is 24? You can just see here we have 24, right? So I have to set the pointer to 24. So by using these 2 probes, we have to fix the length of the nichrome wire. So that length is given here. So for every length, we have to measure its respective voltage. As I already mentioned, throughout this experiment, we are going to take our current as 1 ampere. So 1.0, 1.0, I can write for all the different length. Clear? So throughout this experiment, we are going to make the current as a constant. You can see the monitor of this first multimeter. Because this multimeter is going to measure the current, we have to make the current here as 1 ampere. So that value I written here. So throughout this experiment, we have to maintain the same current. Now what we have to do, we have to set for 24, as we already set the 24 centimeter length in this resistance apparatus. Now we have to find its respective voltage. So where we have to find the voltage? By using the second multimeter. So you can see this multimeter is used for measuring the voltage. So now for this 24 centimeter length of the nichrome wire, we got the voltage here as 0.325. So now I have to write this value, 0.325. That's it. Now by using the current and voltage, we can easily find its respective resistance value. So the resistance formula is given here, R, which is equal to voltage divided by current. Voltage here we got here as 0.325 and the current we got here as 1. So now when you divide this number with this number, you'll get the same number here, 0.325. Clear? Now what we have to do, we have to take the remaining data. Now I have to set the length as 20 centimeters. So you can see I'm not going to touch this 0 because 0 is already fixed. So now we have to set this pointer to 20. Clear? So we set 20. Now for this 20 centimeter, we have to see what is its respective voltage. You can see the screen of the voltage multimeter. You can see 0.271. So I have to record this value here, 0.271. And current is a constant, so we can easily find its respective resistance. So 0.271 divided by 1 is 0.271. Clear? Now we have to go for the 16 centimeter length. So what I'm going to do, I'm going to fix 16 centimeter. Clear? Now for this 16 centimeter, what is its voltage? 0.217. So I have to record this value in the table. 0.217. Now for 12 centimeter. What is its voltage? 0.161. So I have to record this value here, 0.161. And then the last value for 8 centimeter. Let's we set 8 centimeter here. Now for this 8 centimeter, we have to see what is its respective voltage. The voltage here is 0.109. So I have to write this value here, 0.109. Now we can easily find its respective resistance for each length. So here again 0.217 217. So this number divided by this one, we will get the same value, and then this one divided by this one is 0.161, and this number divided by this one is 0.109. So better I can make this number to 2-digit after the decimal. So if you rounded the value, we can write this number as 0.33. We can rounded this number to 0.27, and then we can rounded this number to 0.22, and we can rounded this one to 0.16, and this one is 0.11. Now what we have to do, by using this data, we have to draw the graph. So this is the procedure for completing the data for the first table. Clear? That's it. Now I am going to explain for the second table. In the second table, what we are going to do, we are going to replace the nichrome wire with brass wire. But here we are going to use 4 different diameter brass wire. So you can see the diameter values are mentioned in the first column. And also we are going to keep the length as constant. In the previous video, what we did, we changed the length and then we took its respective voltage. But in the second table, what we are going to do, we are going to make the length as a constant, but we are going to take 4 different diameter brass wire. So its diameter value was mentioned here. I can show you what are the wires we are going to use here. So if you see these 4 wires, these 4 wires are brass wires. The first wire is taking the value. You can see the paper. The first wire diameter here is 0.13, and the second wire, this one, is 0.10, and then the third wire diameter is 0.081, and then fourth wire value is 0.051. So these are the 4 different diameter brass wire. So what we are going to do, we are going to find the value of its respective voltage for each diameter wire. Now what I am going to do, I am going to take the first wire, which takes the value of the diameter 0.13. I am going to fix the first wire in this resistance box, and we have to keep the length as 24 centimeter. So now, so you can see here, we fix the first wire of brass 0.13. So the diameter of the wire which we fixed in the resistance box here is 0.13. Now what we are going to do, we are going to make the current as constant, as 1 ampere. So now you can see the table. Throughout this experiment, we are going to maintain the same current. So let's write current here. Clear? And now what we have to do, we have to find its respective voltage. So you have to see the screen here, and we already fixed the 24 centimeter here, because as I already mentioned, the length should be constant here as 24 centimeter. Now we fix the length here as 24 centimeter. Its respective voltage, we have to take it from the voltmeter. So what's the voltage here? 0.014. So I have to record the value here. 0.0. So now we have to write its respective voltage. So what's the voltage here? 0.014. Clear? Now what I am going to do, I am going to replace the first wire with the second wire. So let's remove this first, and before that I have to turn it off. I am going to take out the first wire. Now I am going to connect the second wire, and this wire diameter is 0.10. So let's take this wire, and I am going to fix it in the resistance box. So the second wire we fixed in the resistance apparatus, and we set the length as 24 centimeter, and now we have to find its respective voltage. So what's the voltage here? 0.022. So I have to record the value here. For the diameter 0.10, we got the voltage here as 0.022. Now what I have to do, I replace the second wire with the third wire. So now the third wire diameter is 0.081. So I will show you the wire here. So this is our third wire, which takes the diameter of 0.081. So now I'm going to fix this wire in this resistance apparatus. So we fix the third wire of diameter 0.081 in the apparatus, resistance apparatus. Now we have to, we already fixed the length as 24 centimeter. Clear? And now we have to take its respective voltage. What's the voltage here? 0.033. So I have to write the value here. 0.033. Now only diameter is 0.051. Now I have to replace the third with the fourth one, and you have to find its respective voltage. So this is the last wire and diameter is 0.051. Now I am going to fix this in the resistance apparatus and I am going to set its length as 24 centimeter. So finally we have to fix the last wire and its diameter is 0.051. Now we have to find its respective voltage and we already set the length as 24 centimeter here from 0 to 24 we already fixed. Now we have to find its respective voltage. So let's see the screen of the multimeter. So its voltage is 0.088. So I have to record this value 0.088. That's it. Now I will explain how to complete this table. So here we are going to find its respective area for each diameter and the formula is given here. So what's the formula? The cross section of the wire looks like area of the circle. So as we know, the area of the circle formula is pi r square, right? But here we are using the diameter. So what I am going to do, I am going to modify this formula in terms of diameter because here we have pi multiplied by radius square. So what I'm going to do, I'm going to convert this radius in terms of diameter. Why? Because in the table we are going to use the diameter value. So how we can convert? You can see here, as we already know, radius which is equal to diameter divided by 2. Therefore radius square which is equal to diameter square over 4. So when you take this value and substitute here, we can modify the equation for the area of the circle in terms of diameter is pi d square over 4. So that will be the formula and that formula is written here and that formula is written here. So it's very easy. What you have to do, take the diameter which value is 0.13 and use the value of the diameter and complete the answer. And for the second diameter, you have to substitute the value of the diameter here as 0.10 and you have to substitute that value here and you have to complete the second one. So likewise, you have to find its respective area for a different diameter and by that you have to complete this table. And once you find the area, it's very easy. We can find 1 over area. That means 1 divided by this answer, you will get the answer. Likewise, 1 divided by the second value, you have to write the answer here. 1 divided by the third value, you have to write the answer. So likewise, you have to use the area and you have to substitute the area. 1 divided by the area, you have to complete this. Once you complete, you can easily find the resistance value by using the voltage and current here. So this is a current, okay? So voltage and current we already have here. So this value divided by this one, it's very easy. We can write it here. 0.014 divided by 1, same 0.014. And this one 0.022 divided by 1, 0.022 divided by 1, 0.022. And then 0.033 divided by 1 is 0.033. And finally 0.088 divided by 1 is 0.088. So once you complete the entire, because here I did not show the calculation for the area as well as 1 over area, it's very easy. You have to use your calculator and by using the calculator and you can find the area for its different diameter and you can complete the remaining 2 columns. So I will make the another video how to do the calculation and in that video I can show you the value for the area as well as 1 over area. So this is the way how to complete the data for the second table.
Now data analysis. After we complete the data, we have to draw the graph for the first table by taking a resistance value in y-axis and then length value in x-axis. So I have to mention what should be your y-axis here, resistance, and its unit is ohm, and in x-axis we have to take length and its unit is centimeter. Now we have to plot all the points here. So here we have 5 points. So you have to take your graph paper and you have to draw this graph in the graph paper only. Clear? So here I mentioned 5 points. Now I have to connect these 5 points by a straight line by using the ruler. Clear? So I'm going to connect all these 5 points by using a ruler. Now I have to choose 2 points. So better we can take the first one and the third one. So let's take, this is our first point and this is our second point. And the most important thing, while you choose these 2 points must sit on the line. So here this is our x1 value, this will be your x2 value and its respective y1 and y1 and y2 are indicated here. Now, by using these 4 points, we have to find the slope value. As we already know, the formula for the slope is delta y over delta x. In y-axis, we took the resistance value. In x-axis, we took the length value. And now, for delta y, this is y2 minus y1. For delta x, this is x2 minus x1. Now we have to substitute the value of x1, x2, y1, y2. And once you substitute, we will get the answer, right? And what's the unit for the slope here? So the unit for the slope here is resistance over length. So the unit for the resistance is ohm, and the unit for the length here is centimeter. So that means the slope value is exactly equal to R over L. Now, what we have to do, we have to find the value of the resistivity for nichrome wire. So for that, we have to use the equation resistivity rho, which is equal to resistance multiplied by area divided by length. So here, this R over L, resistance over length, is nothing but our slope value. Clear? So here R over L is our slope value. And then for area, we have to find the answer. So how to find the area? So if you see the cross-sectional view of the wire, it looks like the area of the circle. So you can find the area here by using the diameter value. As we know, the area of the circle is pi r square. So here we have to use the formula for diameter. As we already know, radius, which is equal to diameter divided by 2. So once you substitute the r value here, you will get pi d square over 4, and that formula is given here. So now, how to find the value of area? We have to use the value of the diameter here. So by substituting the diameter value here, we will easily find the answer for the area. So what's the value here? Pi multiplied by the diameter value is 0.10 centimeter square divided by 4. So let's see what's the answer for this. So I have to substitute the value of pi multiplied by 0.1 square divided by 4, and I got the answer here as 7.854 multiply 10 power minus 3 centimeter square. So this is our area value. Now what we have to do? We have to take this area and we have to substitute here. And we have to take our slope value and we have to substitute here. Once you substitute, you will get the answer for the resistivity value of the nichrome wire. So I'm going to substitute the value. So here R over L is our slope. So slope multiplied by area, we will get the value for the resistivity of the nichrome wire. And what's the unit for this? The unit for the resistivity is ohm multiplied by centimeter. And now we have to compare. So the value what we got here is the resistivity by experiment value. So why I just mentioned this experiment value? Because we have to find the error percentage. So for finding the error percentage, we have to use the rule, the percentage of error, which is equal to the absolute value of the resistivity by experiment answer minus the resistivity of the real value of the nichrome wire divided by the resistivity value of the nichrome wire real value multiplied by 100. Once you substitute the experiment value and the real value of the resistivity, we will get the answer for the error percentage. So once you substitute the value, our answer must be between 0 to 10%. If your answer is between these two numbers, then your answer is perfect. Clear? So this is the calculation for the resistivity of the nichrome wire. Now I have to explain for the second table. So before that, we have to see what is given in the table. So this table is for brass wire. So in this table, what we have to do, we have to fix the length as constant and we have to make the current as constant. But this time we have to take 4 different brass wire of different diameter. Clear? So we have to take its respective voltage, and the data taking video is already shown in the previous video. Now the only thing we are going to get the information how to draw the graph for this table. By using the voltage and current, we have to complete the last column. And by using the diameter, we have to find the area. As we already know, the cross-sectional view of the wire is the area of the circle. So here we are using the area of the circle by means of diameter. By using all these diameters, we have to find its area. Once you find the area, 1 over area, we can find it easily. Now we have to draw the graph between resistance and 1 over area. So for this, in y-axis, we have to take resistance value. In x-axis, we have to take 1 over area. So the unit for the resistance here is ohm, and the unit for 1 over area is 1 over centimeter square. And here also we have 4 points. I have to fix that 4 points, and then you have to connect these 4 points by using the ruler. So let's we connect these points by ruler. I have to draw the straight line, and now I'm going to draw a straight line by connecting 4 points. And for these 4 points, we have to find what's the slope. Again, we have to choose any 2 points exactly on the line. And here I'm going to choose the first point and the third point. And here this is your x1 value, and this will be your x2 value. This is your y1, and this is your y2 value. And now we know the formula for the slope. The formula for the slope is delta y over delta x. In y-axis, we took the resistance value. In x-axis, we took 1 over area value. So now delta y is nothing but y2 minus y1, and delta x is nothing but x2 minus x1. After we substitute the value of x1, x2, y1, y2, we will get the answer for the slope. Now we have to write the unit for the slope. The unit for resistance is ohm, and the unit for 1 over area is nothing but 1 over centimeter square. So if you rearrange this unit, you will get the unit for this slope is ohm multiplied by centimeter square. And once we find this, we have to find the resistivity for the brass wire. Clear? So we are going to find the answer for the resistivity for the brass wire, and after that we have to compare our final answer with the real value. So for that, again we have to use the resistivity formula. Resistivity rho, which is equal to resistance multiplied by area divided by length, right? And here area, I can just re-modify this equation as resistance divided by L multiplied by 1 over area, right? Because here R over 1 over area is our slope, so I can write this equation as slope divided by length. And after you substitute the slope value, and after you substitute the value of L, because here for the second table we kept the length as a constant of 24 centimeter. Once you substitute the value of the slope and the length, we will get the answer for the resistivity of the brass wire. Clear? So this is our resistivity of the brass wire. And what's the unit for this? The unit for the slope here is ohm centimeter square divided by centimeter. So the final answer here is in terms of ohm centimeter. And after we find the resistivity value by experiment, actually this is our experiment calculation, right? Now we have to find what's the error percentage calculation for the brass. As we know, the formula for the error percentage is absolute value of resistivity by experiment minus resistivity of real value divided by resistivity of the real value of the brass multiplied by 100. Once you substitute the value, we will get the answer for this. And your answer must be between 0 to 10%. So this is the explanation for the experiment electrical resistivity.